It starts with a single image, not an official announcement, not a military press release, just a blurry photo quietly spreading across Chinese social media. At first glance, it looks like any other aircraft sitting on a runway. But then you notice something strange. At the back of the aircraft, something is glowing. Not one engine, not two, three. All of them lit up at the same time, burning bright in the dark. A configuration that shouldn't exist on a modern fighter jet. Because for decades, every advanced stealth fighter on Earth has followed the same basic rule. One engine for simplicity, or two for balance and safety. But three? That breaks the pattern completely. And in military technology, when a design breaks the pattern, it usually means one thing. Something has changed. So the question is no longer just what we are looking at. The real question is, why would a sixth-generation fighter need three engines? And what does that reveal about the future of air warfare? Because this isn't just a strange prototype. It might be something far more important. The first real sign that the next era of air dominance has already begun. 2. The reveal. A fighter. Unlike anything before. The more analysts looked at the image, the clearer it became. This wasn't just a modified version of an existing jet. It was something entirely new. The aircraft was first publicly spotted in late December 2024. Since then, it has appeared only in brief glimpses, short videos, distant photos, and unofficial leaks. There has been no formal name, no detailed specifications, no official confirmation. And yet, in military circles, it already has a label, J-36, or simply J-XX, a placeholder name for something that doesn't quite fit into any existing category. Because when experts began comparing its size and shape, one detail stood out immediately. This aircraft may be the largest fighter ever built. To understand why that matters, think about how modern fighters are designed. Aircraft like the F-22 or F-35 are built to be fast, agile, and stealthy, optimized for air combat and precision strikes. They are powerful, but they are still limited in size because they need to maneuver quickly in a fight. But this aircraft seems to follow a completely different philosophy. Its size suggests it's not just meant for dogfighting. It's designed to carry more fuel, more sensors, and possibly more weapons than any traditional fighter. That changes everything. Because once an aircraft becomes this large and this capable, it stops being just a fighter. It starts becoming something else entirely. A platform that can strike targets at extreme distances, collect intelligence across vast areas, coordinate other aircraft and systems in real time. In simple terms, it's no longer just a jet. It's closer to a flying system of systems, a hybrid between a fighter, a bomber, and an airborne command center. And that's the real shift happening here. This isn't the next step in the evolution of fighter jets. It's the beginning of a completely new category of air power. And once you see it that way, the strange design choices, like those three engines, start to make a lot more sense. 3. The design puzzle. Why three engines? Now we come back to the detail that started all of this, the three engines. At first, it feels like a mistake. For decades, modern fighter design has been built around a simple balance. One engine, like the F-35, keeps the aircraft lighter and simpler. Two engines, like the F-22 or J-20, provide more power and safety. But three engines, that adds weight. It adds complexity. It increases maintenance. So why would engineers choose a design that seems to go against everything we know? When analysts studied the images more closely, a pattern began to emerge. The middle engine appears larger than the other two. The side engines are smaller, almost like they play a supporting role. This suggests something unusual. The aircraft may not be using all three engines in the same way. Instead of equal thrust, it could be using asymmetric power distribution, where each engine has a different job. Think of it like a long-distance truck instead of a sports car. A sports car uses all its power for speed and acceleration, but a heavy truck needs a different setup. Enough power to carry massive weight efficiency to travel long distances, reliability to operate for hours without stopping. This aircraft seems to follow that second model, because its mission isn't just speed, it's endurance, range, and capability. A third engine could solve several problems at once. First, sheer size. If this is the largest fighter ever built, it needs more thrust just to get off the ground, especially when fully loaded with fuel and equipment. Second, long-range efficiency. Instead of running two engines at full power all the time, the aircraft could adjust how many engines are active, optimizing fuel use during long missions. And third, and maybe most important, power generation. Modern combat aircraft don't just burn fuel, they generate electricity, massive amounts of it, for radar, for electronic warfare systems, for onboard computing, and possibly, in the future, for directed energy weapons. In that context, the third engine stops looking like a strange choice. It starts looking like a necessary one, because this aircraft isn't designed for yesterday's missions. It's built for a future where air combat is no longer just about speed and maneuverability, but about power, data, and endurance. And once you understand that, the real question changes again. Not why three engines, but what kind of missions require this much power in the first place? To understand why this aircraft looks so different, you have to look at what it's designed to do. Because its mission changes everything. According to multiple assessments, this aircraft could have a range of over 8,000 kilometers. That number is easy to hear, but hard to fully grasp. So let's put it into perspective. 8,000 kilometers is roughly the distance from China to Hawaii, or from Europe to the middle of Africa. Most modern fighters can't come close to that without refueling in the air. They rely on tanker aircraft, forward bases, and carefully planned logistics just to stay in the fight. But an aircraft with this kind of range? It doesn't need to depend on those systems nearly as much. It can take off, fly thousands of kilometers, carry out its mission, and return, all on its own. That changes how air power works. Instead of operating close to home or from vulnerable bases, this aircraft could conduct missions deep over the Pacific Ocean, far from support. It could monitor or strike targets more than 4,000 kilometers away. And it could do so without relying on aerial refueling, which is often one of the most exposed and fragile parts of any air operation. In simple terms, it reduces one of the biggest weaknesses modern air forces have. Now compare that to traditional fighters. Most are designed as tactical tools. They're fast, agile, and deadly, but they operate within a limited range and usually as part of a larger system. This aircraft is different. It behaves more like a flying command center, a platform that can stay in the air for long periods, gather and process huge amounts of data, coordinate with other aircraft, drones, and sensors. It doesn't just fight battles. It helps manage them, and that's the real shift. Because when an aircraft can operate independently, at long distances, with massive onboard systems, it stops being just a fighter. It becomes a strategic asset, something that can project power across entire regions without needing constant support. And that has huge implications, because if you can operate this far, this long, and this independently, you don't just change how battles are fought. You change where they can happen. 5. Hidden engineering, the power behind the machine. But range and size are only part of the story. To really understand what this aircraft is trying to achieve, you have to look at what's happening inside the engines. Because in modern air combat, engines are no longer just about thrust. They are about energy. Traditional jet engines face a constant trade-off. If you design them for maximum power, they burn more fuel. If you design them for efficiency, they produce less thrust. It's always a compromise. But a new type of engine is trying to change that. It's called an adaptive cycle engine, sometimes described as a three-stream engine. And the idea is surprisingly simple. Instead of one airflow path, or even two, the engine has a third stream of air that can be controlled separately. That means the engine can change how it behaves in real time. In one mode, it can act like a high-efficiency engine, saving fuel during long-distance cruise. In another mode, it can shift into high-thrust performance, delivering the power needed for combat. And that third stream does something else that's just as important. It helps manage heat, because modern fighter jets generate an enormous amount of it. Think about what this aircraft is expected to carry and operate. Large, powerful radar systems, electronic warfare equipment that jams or disrupts enemy signals, advanced onboard computers processing data in real time, and possibly even laser-based systems in the future. All of these systems produce heat, and if you can't manage that heat, they simply won't work. So cooling becomes just as critical as speed. And this is where engine design becomes a strategic advantage, because the more efficiently you can generate power and control heat, the more advanced systems you can carry. In other words, the engine isn't just moving the aircraft forward, it's powering everything the aircraft can do. You can think of it like this. Older fighters are like high-performance cars. But this new generation? They're closer to mobile power stations in the sky. And the country that masters this kind of engine technology doesn't just build faster jets. It builds more capable ones. Ones that can see farther, process more information, and potentially use entirely new types of weapons. Which leads to a much bigger question. If this kind of technology is possible, Who is actually closest to making it work at scale? Once you start looking at the technology behind this aircraft, it becomes clear that this isn't just about one country building a new jet. It's part of a much larger competition, a quiet race that has been unfolding for years. On one side, the United States, a country that has led fighter aircraft development for decades. On the other, China, moving quickly, investing heavily, and closing the gap faster than many expected. One of the most important areas of this race is exactly what we just talked about: next-generation engine technology. The United States had already been working on this idea through a program known as the Adaptive Engine Transition Program, or AETP. The goal was ambitious: to create engines that could switch between fuel efficiency and high performance, giving future aircraft a major advantage in both range and combat capability. It was meant to push aircraft like the F-35 into what some called a 5+ generation standard. But despite the promise, the program ran into a familiar problem: cost. Developing, testing, and integrating these advanced engines proved extremely expensive, and eventually, the program was canceled, leaving the technology unfielded in operational aircraft. Now compare that to what we're seeing on the other side. China appears to be pushing forward, not just in theory, but in hardware: multiple prototypes, rapid testing, visible progress. And the timeline difference is striking. The United States' next-generation fighter program is expected to see its first flight around 2028, with operational service likely in the late 2030s. Meanwhile, based on current progress, China's aircraft could potentially enter service in the early 2030s. That's not a small gap. That's a shift of several years, in a field where timing can define strategic advantage. Historically, the United States has taken a slower, more cautious approach: longer development cycles, extensive testing, highly refined systems before deployment. China, on the other hand, appears to be moving faster, building, testing, and iterating at a pace that's difficult to ignore. And that creates a new kind of uncertainty. Because for decades, the assumption has been clear: the United States leads in advanced air power. But now, for the first time in a long time, that assumption is being questioned. Not because the United States has stopped developing new technology, but because someone else may be moving faster. And in a race like this, speed matters. Because the country that gets there first doesn't just gain a new aircraft. It gains experience, data, and operational advantage that others have to catch up to. Which raises a critical question: are we witnessing a shift in who sets the pace for the future of air combat? 7. The evidence: rapid prototypes and real progress. Up to this point, a lot of this story might still sound like speculation: new concepts, future technologies, possible capabilities. But then, you look at the one thing that matters most: evidence. Because this isn't just an idea on paper anymore. It's something that's already being built and tested. According to available reports, at least 4 different prototypes of this aircraft have appeared in just about 13 months. That is extremely fast. To understand how unusual that is, consider how aircraft development has traditionally worked. In the past, building a new fighter was a slow, step-by-step process. One prototype is built, it's tested for years. Problems are fixed, then the next version is developed. This could take a decade or more before a design is considered ready. But what we're seeing here looks very different. Instead of moving in a straight line, development appears to be happening in parallel. Multiple prototypes, each slightly different, each testing new ideas at the same time. This approach is only possible with advanced digital design tools. Engineers can simulate performance, identify problems, and refine designs before the aircraft even leaves the ground. So when a prototype is built, it's not the first version of the design. It's already the result of thousands of virtual tests. That dramatically speeds things up, and the details in the images support this idea of rapid evolution. Take something as simple as the landing gear. Recent images show a wider landing gear configuration with wheels placed side by side instead of in a line. That might seem minor, but it's actually important. Wider landing gear usually means a heavier aircraft, higher takeoff weight, more fuel, more equipment, or more payload. In other words, the aircraft is growing more capable with each iteration, and that's exactly what you would expect in a fast-moving development program. Each new prototype is not just a test, it's an improvement, a step closer to something operational, which brings us to the key point. This is not a concept, this is not a distant plan. This is real hardware, evolving in real time. And when you see that level of progress, it changes how you look at everything else. What once sounded theoretical now looks increasingly possible. 8. Conclusion: the moment that changes air power. Go back to that image one more time: a runway, a shadowy aircraft, and three engines glowing in the dark. At first, it looked like just another leak, another piece of speculation in a world full of rumors. But now, after looking at the design, the mission, the technology, and the pace of development, it feels like something else entirely. A signal. Because what this aircraft represents is bigger than any single feature. It's not just about three engines. It's not just about range. And it's not just about speed. It's about a fundamental shift in how air power is designed and used. For decades, fighter jets have been built around one idea: win the fight in the sky, be faster, be stealthier, be more maneuverable than the enemy. But this new generation is moving in a different direction, toward aircraft that act as multi-role platforms, not just fighters, mobile networks, connecting sensors and systems across vast distances, flying power stations, generating energy for advanced electronics and future weapons. In that world, air combat isn't just about pilots and missiles anymore. It's about information, endurance, and control over the battlefield as a whole. And an aircraft like this could make that possible on a scale we haven't seen before. If it delivers on even part of its potential, it could redefine what air superiority means, shift the balance of power in critical regions, force other nations to rethink how they design and deploy their own aircraft. Because once one country changes the rules, everyone else has to respond. And that's how new arms races begin. So the real question isn't just about this one aircraft. It's about what comes next. Are we witnessing the birth of the world's first true sixth-generation fighter, or the beginning of a new kind of competition in the skies?